Let's turn off the... All right. Hello, everybody. Finally, yes. Thank you for coming. Today is the second ever Sound Hackers meetup. So we're really excited to have you here. And we've got new and improved, exciting AV stuff now with actual stereo sound. Woo! And more working microphones. That's definitely an improvement on last time. So thank you for coming. I am going to be introducing our guests, but first of all, I'll just tell you what the point of all of this is. I can hear something going on in the background. Is there like some music still playing? Oh, would you mind muting that while the talks are going? All right, thank you. Okay, so the point of Sound Hackers really is for people who enjoy making noises and making things that make noises to get together and share how they make those things. And the point of that really is to raise up our game as collectively as a community and just see what is out there, see what exciting things people are playing with, and really get hands-on with some of the cool new tech. I try and make a balance of artists to community work, to people doing work in the community, to people who are making products. So I try and make that balance every time because that's, we've got all sorts of things. Sorry, there's still some music going on? Is it? Oh, okay. Okay, thank you. It's very distracting hearing things in your head. All right, so before we get really started, I just wanted to give a big shout out to my employers, Crowd Supply, for letting us meet here, which is great. So thank you very much to Crowd Supply. Whoop, whoop, whoop. And also a huge shout out to Microchip, who paid for all of our beers tonight. Thank you, Microchip. Woo! They have great components. All right, so without further ado, I would like to introduce you to our first speaker tonight. So some of you may well already be familiar with their work, but they are a great community organization called Portland Synth Library. And today we've got two people from the community organization to explain what they're all about. And also they brought some fantastic synthesizers for us to have a little play around with later as well. So we've got lots of things to make bleeps and bloops on. Oh, one more thing I need to tell you before I bring on the Portland Synth Library is we're trying out a tip jar. This is a free, we've got Microchip to pay for the beers, or this is a free event. So anything, I'll put a tip jar over by the drinks. And if you want to put some money into that, it will be split 4 ways between the artists. So any money you put into that will just be a thank you for the people who are putting on tonight's evening of intellectual entertainment. So without further ado, here we go. Here's Portland Synth Library. Please give a big welcome to them and play with their synthesizers.
All right, I'm gonna take this off. Thanks everybody. We're Synth Library Portland. We are a local nonprofit. I'm Max Jursak. I'm a staff and volunteer.
And I'm Thomas Feng.
Yeah. So we're not going to talk for super long, but we'll just kind of give you a rundown of what we do as an organization. We're a nonprofit that provides low to no cost access for music equipment, electronic music equipment, education, pretty much everything in the sort of AV art space. So we used to have a physical location, but currently we are primarily like a lending program. We do a lot of workshops. We put on events, and we're pretty much a volunteer-run sort of entity. We do have a large collection of equipment that's been donated through this wonderful, weird synth community that we have here. I know we have at least one maker in town that's with us tonight who's donated equipment, but there's lots of local manufacturers and individuals who have over the years provided us with gear. Thomas, I think you're going to talk about some of the history and yeah.
Sure. Also, just to highlight what Max was saying about there being local makers who have donated synths to us, we brought some equipment tonight by 3 local makers. They are Moffensief Modular, Schlappy Engineering, and 4MS Company. They're all local Eurorack synthesizer manufacturers who are doing great things. And so we brought a bunch of their gear for folks to play with. These are also specifically systems that students can check out and take home. So the way our lending program works is we have a website where all of our gear that we lend out is listed, and you can check out up to 2 synths for a 2-week cycle. And those are anything from keyboard synths to MIDI controllers to effects pedals. We've got books and DVDs about synthesis, and lots of modular gear. So lots to explore there. And really in keeping with our mission of lowering the barriers to access for these tools, we understand that they can be really cost prohibitive and expensive as a hobby or as instruments. So we're making them available to people who might not otherwise be able to afford them. There's a very low cost monthly membership starting at $10 a month to participate in the lending program, but also we don't want even that to be a barrier. So if people have financial need, they can talk with us, and we offer memberships that are actually below that or even no cost. So this is something that's a newer program within the last 2 years that we started doing, and it's been quite successful. But before that, as Max mentioned, we had our own space. We started off in 2016 inside of a space called S1. And it was first located in the Hollywood neighborhood underneath the Rite Aid. And we did concerts and artist residencies and other events as S1. And Synth Library was kind of an independent program within that, where we had a recording studio set up with synthesizers for students to come to, and facilitators were our staff members who would do hands-on one-on-one teaching for students. And so after several years, we moved to a space on Northeast Sandy Boulevard and did similar programming there, but we were forced to give up that space during COVID because it wasn't safe to have events during the pandemic. And so we were spending a lot of money on rent for a space that we couldn't use. So we closed down that space, but since then it's actually allowed us to be more flexible in terms of doing things at other venues. So as examples of that, we've done some DIY synth workshops at PCC in the Interactivity Lab, and also some workshops at SETI on the PSU campus, which has been a great home for us. We've also done residency at Portland Institute of Contemporary Art, where we had some open hours with gear setup where people could come to us, and then we also had specific workshops around synthesis topics. We've also started doing a new series of workshops at an introductory level at Control Voltage, that is the synth retailer on North Mississippi. And we'll definitely be doing more workshops later this year and into next year on a lot of different topics related to audio and video synthesis.
Yeah, absolutely. So some of our programming outside of workshops includes kind of helping to put on sort of community events. We sort of spearheaded the modular on the spot outside performances over the summer. And we're hoping to do a sort of in-spirit continuation of that into the winter. I'll talk about that, or that'll be coming up later. Let's see. So yeah, a big part of our org is kind of trying to get not only get gear and education into the hands of people who wouldn't normally have access to it, but also sort of being that encouragement, bridging that gap for people who might be on the outside of performance or there's a wide gap between audience and performer, and we're trying to sort of lower that barrier, providing sort of yeah. So we do some of those events. We're volunteer run, and so we're always looking for folks to join up and put on workshops. So I know there's a lot of really talented people here in the audience. We do a lot of DIY programming as well. So if you ever want to get involved with us, we're regularly adding to our volunteer sort of group. So here in a couple months, we'll kind of have like a volunteer onboarding thing. But if you want to join up, you can always just come up and speak to me or Thomas or Matthew. Matthew Rempes is going to speak last, but he's a huge part of the library as well. Yeah, let's see. What else?
I guess we could talk for a second about some of our other programming too. We have a partnership with Hollywood Theater and have been sponsoring some screenings of documentaries related to synthesis. And so Sisters with Transistors was the first of those, a really wonderful documentary about the pioneering women in synthesis. And then also more recently, Moon is the Oldest TV. It's a new documentary about Namjoon Paik, the father of video art. Video art is definitely important to us. You'll get to see some of it being created live for you in a little bit when Matthew shows you his setup, but also we have regular free events that are hosted at SETI that are called Video Mixer. They're informal gatherings that anyone can attend, in which we actually set up different stations with tools of video art, including synthesizers, and anyone can use them and learn about them. And we usually have a guest presenter for those as well. There's one coming up on November 4th at PSU. And also there are some postcards floating around that say our website. It's just synthlibraryportland.com. We have an upcoming events page there where we post about upcoming events, and we also post on Instagram.
Yeah, I think that's a good point about the video mixers, is just to reiterate that we're not just like an audio synthesis only, or like an audio hardware Eurorack modular thing. Pretty much anything in the electronics arts world. So like it could be live coding, you could be working with game engines, you could be software, hardware, DAWs. It really runs the gamut, and we're always open to pretty much if you think it might fit, it will fit within our purview. Yeah. See. So we might think of something else here in a second to mention, but we are going to give you an opportunity to kind of come up and play with some of our synths, which these are all modular skiffs that have been donated to us that are part of our lending program. So if you wanted to join our lending program, every 3 weeks, I lead in just a quick hour Zoom orientation to kind of onboard people. Usually we ask our members to provide a membership, a monthly membership fee, but like all of our programming, we also provide lower, like sliding scale access, or even no cost access. So pretty much all of our events are low sliding scale to free tickets, if that's what works within your budget. So that's really important for us to completely destroy the cost barrier to access. So yeah.
And I guess it's also important too to mention that we're definitely aware that synthesis has been a male-dominated hobby for a long time. So we're really trying to reverse that gender imbalance as well, in terms of helping performers get access to performance opportunities, in addition to just physically getting access to the gear through our lending program. So equity is something that we think about a lot, and we're also looking for further partnerships with other local venues and nonprofits. So if anyone here tonight has any ideas toward what Max mentioned, workshops that you might be able to help with, but also spaces and other kinds of collaborations, then please do let us know. We have done some good partnerships with other nonprofits here locally and are hoping to expand that in the coming year. I guess I should check with Helen and see if we should wait and let everyone jump on the synthesizers after everyone else has spoken tonight.
Yeah, let's
okay.
wait, because otherwise there'll be earth and Diane. So basically all of this, yeah, you can explain.
After everyone has spoken, we'll be over here and help you make a patch and make some crazy noises over here in headphones. There are 3 different systems, so 6 people at a time can be over there and maybe help each other out with making some sounds, and then step back and let some other folks use the gear as well. But that'll be after a few more presenters.
And if you're unfamiliar with the world of Eurorack modular synths, you should definitely come to our next intro to modular synthesis class over at Control Voltage, which we're doing every 4 or 5 weeks right now. So just check out the calendar. We're always adding new events. Yeah, we hope to hear from you. If, like I said, if you're interested in volunteering, getting involved, it's a great way to meet other interesting musicians and sound hackers in the community as well. So, cool.
Thanks, everyone.
Thanks.
All right, thank you so much for that amazing organization, and I hope you do check out some of those events as well. I didn't know you did the Hollywood things. That sounds really awesome. So next up, we've got Lara Grant. Lara is an awesome interdisciplinary artist and a rad human being who makes PCBs and sews and does all sorts of cool things. Do you need a minute to set up, or should we just dive into it? Do you want this microphone?
And then we'll actually, yeah, I will do that. Can I mute the remote one? I don't need to be on.
Leave this one here. Two.
All right, well, we get to...
Okay. Cool. And then
also, if you see me running around pointing my camera at things, I'm doing a down cam for the people on the stream. I'm not, okay, just FYI, that's what I'm doing.
Okay. Hi, all. I'm really excited to be here. This is the second one only. I missed the first one, so I'm really excited to hang out with y'all. So first, before I get into what I brought up to show here today or to noodle around on, I'm going to go through a little bit of my past work to give a bit of context. I haven't prepared any slides. I am just gonna click around on my website. So it'll be a bit casual. It doesn't seem like I'm in the way here, right? You can still see? Okay, great, thank you. There's just a little bit, right? But not that, okay. My ports are just so tricky as well. It's not working, right? So I'm gonna go ahead and unplug and try, oh, is that what it is? Oh, interesting. It's my second screen. I do have a Mac, yeah. Well, and I also just lost my the Wi-Fi here. Lost your Wi-Fi? Yeah, the connection. It was, okay, let's try this. so funny because, you know, we take a good at least 10 minutes to set up before y'all guys come here. There's still always a little bit of, here we go. All right, displays. Yeah, it was mirroring before, so I'm just. Yep, should be mirroring. Here we go. Oh my gosh, this is very frustrating. Okay, right. So it's showing something that I do not need to show, that's for sure. Okay. No. All right. Jeez. Oh my gosh. Come on. We can do this. Yo, just if I can close all of it. Okay, that's the Adobe. Okay, wow. All right. We're getting there.
It's okay. NASA blew up a lot of rockets before they got to the moon.
I mean, and then they have backup to like at least 3 computers on each rocket. Yeah, in case one fails. Yeah. Okay, here we go. So what I brought for you all today is it's a toy battery operated sewing machine that I modded to act somewhat like a sequencer. But before I got to that, I thought it'd be fun to go into a past project of mine that is really a continuation. Like this is a continuation of that in a way. So around like 2010, I was in this class at school called NIME, and it stands for New Interfaces for Musical Expression. It's actually inspired by the conference that happens. I don't know if anyone's familiar with that conference. I think it still goes on. Yeah, they like travel around the world really and like hold it in different countries. So it's super open-ended, the class was, and I am not a musician. I actually was a seamstress for many, many years. I worked as a production seamstress, so working with industrial machines. I'm very comfortable mechanically with a machine and also operating it. So I was like, well, sewing machines are very percussive, and I feel like I'm already very good at using that kind of interface. So I went with that, and that's kind of how I began my experimentation with using sewing machines and making them into musical instruments. So my first project was 16th and Mission, which is a corner that I used to have a subterranean sewing studio with my friends in San Francisco. And I also have worked as a pattern drafter as well. So like a flat pattern drafter that you cut. I'm going to time myself too, because I feel like I could easily start rambling here. So let me just make sure I don't go too far over. So I draft patterns for cut and sew for garments. And so I was like really interested in figuring out how to work that into it. And I wanted to, I mean, you learn. Every sewing machine is different. It really is. And you get to know its temperamental mechanisms and like how to work with it. And not working and you don't know why, with a lot of other things, which I think people here have probably experienced. So it was really easy for me to kind of like want to pour my emotions like into that as a musical interface too, like the struggle but also like the choreography. It's like when you're sewing, like you're lifting up the needle bar, you're feeding the fabric, you're back stitching, like there's all these coordinated movements that you learn. So it made a lot of sense. So that's kind of where I started. You can see there's, so this is the first sewing machine that I ended up modding, with the second sewing machine here that I used for a performance, and then a garment here that I was building with, I was embedding conductive fabric into it. And there were like 2 things that I kind of landed on. So I wired the sewing needle, which I'll just go ahead and show a photo of that, jump ahead to that. So this is a really simple concept. Like I just wanted to trigger a sound when the sewing needle went down. And so I put some conductive fabric underneath and I wired the needle up, and those are your two sides of a switch. So then when it closes, it can trigger whatever sound you want. So the first one that I did, I used Maximus P. So I used like a microcontroller that then was connected to my computer, and that's how I did my sound generation through Maximus P and just using my Mac. So these are just some detailed shots. Oh, and I knew nothing about electronics. So this is me getting very intimate with the potentiometer. You know, trying to figure out, because there are, just like a volume knob, like potentiometers are everywhere. And so the sewing machine is no exception. So I was trying to figure out like how I could mod the actual machine just past the needle being a switch with the conductive fabric in interesting ways. I don't think I got anywhere with it because I just really was still learning how to do things. And then also I was electrifying the needle, which is connected to a metallic part of the sewing machine. And so that was electrifying like other parts of the machine. Sorry, I feel like I'm doing a little breathing into the mic. So the throat plate that the needle goes through, and that this sewing foot here touches, which is usually metal, I needed to make it plastic because otherwise it's going to be triggering all the time. So that's why these are made out of old health insurance cards and credit cards. And then this is a plastic sewing foot that you can just buy from any machine or any sewing supply store. And, you know, and I got super experimental with like how I could, you know, come up, not just have like a switch on and off, but, you know, have that variable resistance that I could then play with as like a sweeping, you know, like a potentiometer. So I was trying to like figure out if I could, you know, sew some conductive thread and have it become more resistive over time and whatnot. And it's too tricky, honestly. It really is. I was able to get some really interesting things out of it, but I used to work a lot with e-textiles. I still do, but it's way more on like an educational kind of like getting electronics in front of people who don't usually like work with electronics, you know, different demographics and whatnot. Not so much like, you know, trying to build a product or like something that works all the time because they are very noisy and very flexible materials, and they're beautiful for that reason. But I went through a phase, and now I'm definitely back into I feel like I've always kind of been in the research educational phase. But so this was a second variation I did. Sorry, my photos aren't that big. Hopefully we can still see them enough. This was the second variation I did. I feel like every time I do another variation of this project, I perform it. And sometimes the performances turn out to be complete disasters. Well, you know, actually, my first one was a complete disaster. The second one with this one was not a complete disaster. It was this one, I added looping. Because I'm sewing through, like I was sewing with conductive thread, closing switches that were made of conductive fabric. And then I also was using the needle, hitting the conductive fabric as a switch. So those were like my two main things. And then I always had the motor mic'd because it's so percussive, the thing in itself. So I always had that. And like, of course, running through a whole bunch of like cool guitar pedals because hello effects, like why don't you ever want those? And so, right. So this one was like trying to get a little bit more, you know, repetitive, you know, just so I wasn't like doing the same thing. And I'm not a composer, and I was just like trying to figure things out. So this recorded, so I would sew through some stitches that would then trigger noises. And I was using my computer to generate the sound still. So it was like really high def. So I was doing like a mandolin sound, you know, just something really pretty. And then it would record that pattern, then it would play it back. And then it would play back, and then I would record on top of that, and it would play back. So it would just be like this building thing. Okay, so that's pretty much what got me to where I am. Well, with this little machine here, I've always thought like I just still want to keep on the percussive tip and trying to figure out like how to go further with it, because I love building. I have some of my Eurorack modules up here. I have like half of my setup up here, and I have a lot of hand-built electronics and whatnot. But I feel like, yeah, I feel like I've learned a lot just building through modules, and I'm not so much, sometimes I think I like building more than actually playing. And so I don't really play a whole lot of music. I don't really play out that often, but I love, love, love designing, and I love building and learning through that. And there's such great people that I've learned from online too, which I'm happy to share with all of you if you come up to me later on. And yeah, there's some great online resources. So, right. Okay, so from 60th and Mission, I'm taking the same simple idea of the needle hitting conductive fabric to close a switch. But this time I'm not using, I really wanted to get away from my computer, like as far as sound generation. And, you know, it makes things a lot more raw and a lot more simplistic and sometimes annoying at times, like as far as sound, but only because I'm getting to know my instrument, right? I mean, there's a lot of, you know, there's a lot of opportunity here to create a lot of different sounds. So that's where I've gotten to right now. Oh, right. So this machine, what I ended up doing was I ended up removing the motor, and it was important that I got a battery operated machine because I don't mess with I do not mess with wall voltage and the amperage from that. And so I knew that I could replace the motor in a battery operated one very easily and control it with a microcontroller. So it's a DC motor that essentially that I replaced with a stepper motor. And I only really had to replace one gear. So I just kind of like cut into the housing that was already part of the sewing machine. I put in my stepper motor. I took off one of the, I had to get rid of the gear that was attached to the DC motor because it came with. And so I had to find another gear that would then mesh with the gears that were inside of the sewing machine. And it wasn't that difficult. I actually found a great selection. I was able to get the right pitch and the right number of teeth for it from a hobby, like an airplane model building hobby store. So great resource. And so the idea was I wanted to control even more like the timing of when the needle went up and down and hit the fabric and how many times it went down and how long it would stay down. And I just wanted all of that control. You can do that with the pedal of a sewing machine, and like with also there's a knee lever as well that is used for industrial machines, but it's not super accurate, right? So I wanted something that was give me a little bit more control. So I have 3 different speeds at which the needle can go up and down. And then I've broken up each of those speeds into periods of time. And I have 8 different switches up here that I can either turn on or off. And so if it's on, then it will go up and down. And if it's off, then it will pause. So that's what I have going on now. And I've hooked up the switch to trigger many different kinds of things. I think right now so I have a built-in oscillator in here, which is super simple. It's just a square wave and a triangle wave. I keep it on the square wave because I haven't really amped up the triangle wave to be loud enough at this point to do anything very interesting with as far as like performing. But then I also have a Worksat 01 Moog little synthesizer, and this was built, but it was also something you could build during the Moog Fest. I don't know if anyone's familiar with that. Like it's an art music festival that happens in Durham. The Moog factory is in Ashland. Is that right? Yeah, Ashland, North Carolina. So I went there one year and I bought one. It's fantastic. It has everything built into it. So, and to keep things simple, like I've had this connected to my, oh, sorry, that's the panel with the switches. I was supposed to be showing you images as I was talking, but, oh yeah. So I usually have it hooked up into my Eurorack synth situation, and I can get some really cool things going on because it's like, then I can work with noise and just so much more. But for you here today, I wanted to keep things simple. So I'm just working with the Works.01. And I did bring some of my setup here. It's really just to use the delay module because that always sounds cool. I'm not sure if I'm going to though. And then let's see what else. I have a mixer here. Oh, and then I also have, so I'm really interested in building kits, and I've brought some for you, like, or to show you today, like after my performance. I am using one of them in my performance, and it teaches you like about, okay, is anyone familiar with Handmade Electronic Music, that book? Okay, yes, okay, rad, awesome. Okay, right, so yeah, Nick Collins, Nicholas Collins, he wrote that book. It's based off of a lot of different recipes and schematics you can find out there that many people have written. And it primarily uses CMOS Series 4000 integrated chips, so like little ICs. That's what I base all of my, yes, oh, there it is. There we go. That's the book. It's beautiful because you just learn the relationship of, at least for me, of like resistance and how capacitors work, and you can build an oscillator with like 3 components. It's just beautiful. It's amazing. So it's a great place for me. Like I learned a lot from it, and I like to build my kits around that as well. So this one is, yes, very simple, square wave. It uses the 4106 chip. And then I've just broken out some sewable pads that you can sew conductive thread to. So the kits that I designed, like they're supposed to teach you a little bit about electronic, like, oscillators and like a sound generating circuit. And then they also teach you like a fiber skill. So this one would be, you would learn how to cross stitch. And then I have another one that teaches you how to spool knit. And like there are these, anyway, you can see after I do a little, like I'm done here. But yeah, it teaches you how to like knit your own sensor essentially. And then you can play with that. And they're like soldered together, your own kits. So that's the other thing that I have here. Cool. Oh, and I've been talking for 14 minutes. It's not that bad. So I feel like that's perfect. Cool. So why don't we just go ahead and see what this sounds like? Come on now. Let me see. Oh, I do want to say that I have performed this with this before, and and I do the larger machine sometimes, which is a video here, but we don't have sound hooked up to my computer, so I won't bother with that. But the second to last time I performed with this, it was in Seattle, and I have to tell you, it was a disaster. It didn't seem like a disaster from the outside, thank goodness, but on the inside, I was melting with stress and anxiety. Basically, like this completely, it broke in like 3 different places. I was able to solder something right before the performance, but it was low light and I didn't fix everything, so it just wasn't working. And I'm performing with 2 people who are like serious musicians on this stage, and I was just like, oh my god. I was very proud of myself, I have to say. I went through it like nobody knew that I was just melting on the inside and that it was just a total disaster. Like I had no idea what I was doing before I went up on that stage at all. Luckily I had a second sewing machine that I just worked the whole time, and I had this like modded cable that I threw in, and I like worked that somehow. But whew, man, it was stressful. I have to say that, like, performing, right? I don't even, sorry, I just wanted to give that little anecdote because I'm just like, oh, and like, yet here I am performing for you all. No, the thing is I, it's an experiment. So we'll see what happens. But yeah, okay, great. So let's go ahead and end that. And then should I just pull this out? Is that okay if I, just to get it out of the way? Yeah, okay, cool. Oh yeah, I feel like we haven't had that up yet. Yeah, let's put that up. It's really cool. I'm gonna shut this off too. You don't need to hear me go, ooh, ah. Why don't you just give it to me? How do I, okay, can I just go ahead and, okay. I'm always so scared of them. Figure out a way to like properly, oh, sorry if anyone can't hear me, to properly like figure out how to time it. I think I have to reset my needle every time I like change my speed. But anyway, you'll see me, I have a manual up and down for the needle because sometimes I have to like manually change it or like adjust it when I'm playing.
Any last words on the microphone?
I'm just really excited to, I mean, the Synth Library, fuck yeah, super excited about that. And all the other speakers, I'm so excited to learn about, just learn more. I'm a forever student.
Thank you so much, Lara. Give it up. That was awesome. All right. Oh my God, that's very loud. Next, we got Mykle, who is going to tell us about the time he reverse engineered the Teenage Engineering Pocket Operator and made a cool add-on board for it. So we're going to learn about how he did that and what it was like to actually hack something together and then make it into a product. So here we go. Give it up for Mykle. I'll get your slides up.
Is this the right way to do it? Okay. Don't know if anyone can hear me yet.
HDMI.
Oh, you can hear me now. Wonderful.
Where do you want to go?
Oh, I would go maybe like here, so I can indicate a little bit
Let's
over
not
that
smash
direction.
into Matthew's things.
Oh yes, of course not. Oh, maybe just a tiny bit. No. Oh, wow! Thank you, Lara, for showing us this awesome instrument. It's really fantastic. I love sewing machines, and everything mechanical sounds so beautiful. And I'm really a big fan of the Synth Library. I gotta say, aside from every other thing that those guys do for Portland and for all of us, they also just hosted a really amazing performance a month ago of a visiting musician, this guy MB, former member of Bird Songs of the Mesozoic, and a few other local Eurorack people, put on just the most exquisite performance in a quadraphonic audio setup in this local church. It's one of the most excellent like sound fields I've been in a long time. So I'm really happy that so many people at the Synth Library are helping us to hear newer and better sounds. I can't really take that off unless I put this in my pocket, can I?
All right, your slides are open.
Hey, it's my slide. Hi. So I'm Mykle. This thing here, I'm sort of generally here, is the Pocket Integrator. And I show this picture to a lot of people and they're like, oh, wow, that's amazing. You made all of that? No, I didn't make all of that. Almost everything you see here is a drum machine made by this company, Teenage Engineering, known as the Pocket Operator. And the world is divided into those of us who know those things and those of us who don't. They made the drum machine an object that you can just carry around in your pocket all day and have on the bus with you and in elevators and all of the places where you play with your phone, you could play with a drum machine instead. And I got really deep into playing with my pocket operator many years ago, and I really started to think a lot about how it could be used in public and with around other music and other musicians, because I'm like a drummer, I'm a live musician. And then I lived in Berlin for a while and worked on various sound and audio experiments and inventions. That's sort of been my obsession for the last decade. Next slide. I spent a lot of time in Berlin working on this very complicated, weird 4-channel performance looper, reverser, effects engine doodad that became a big, huge headache and became incredibly difficult to continue on and just sort of kind of blew up. And I stepped away from that project. I said, I need something simpler. And I got back to playing with the pocket operator and got back to this idea that I had that if you could just like shake it, you know, like you would shake any other thing in your hand to make it go, that you could just go up to any kind of piece of music and listen to it and play along with it with the beats that you've programmed into it. Next slide. Good, thank you. Very good. So in Berlin in 2019, this was version 1 of the Pocket Integrator, what became the Pocket Integrator. This is a teensy 3.2 development board. These fantastic little boards made in Portland by Paul Stoffergen's company. And below it here is a little add-on that they have that's what they call the prop shield, and it's got an accelerometer on it. So this whole thing had an accelerometer on it. There's a couple wires missing, but there's these 2 buttons that are hooked up, and there's an audio output here and here, and I don't even know what I was trying to control with the pot here. But I figured out how to get this thing to know that it was being shaken and detect downbeats and create audio sync signals and send them to my pocket operator, and I could shake it and it would work in time. And I was like, it works, it's amazing. Someday I should do something with this. And then I had a bunch of other adventures in 2019, and then 2020, I didn't really do a whole lot. I kind of, for various reasons. But in 2021, at some point, I got interested again in the idea of doing something with this. And part of it is like, okay, for this to really work, you'd want all that to be in one package together. And I don't know how to do that. But I got kind of interested in learning about this. On the back of every pocket operator, there's this little set of pads. When Helen described me as having reverse engineered the pocket operator, what I really did, next slide, was I employed the Google search engine to discover if anybody else had already reverse engineered the pocket operator. There's this fantastic site called hackingthepo.weebly.com where somebody has completely torn one down and gotten deep into just about everything that you can do from the outside. The firmware is locked, so you can't really look at its firmware, but he definitely explained what all of these pads do. And I figured out, oh my God, you've got 3 volts from the battery and ground, and the play LED lets you know if it's playing or not. And there's, I guess, some debug stuff you could, eventually I learned you could just reprogram it with if you needed to do that, but you can tell whether or not the codec's on, and you can ground it, and you can read, I mean, you can do a lot with this. So I wondered if I could find a connector that would just hook up to that, and I found one. And so I decided I should try and make my thing again and actually have it be a board that fits on the back. So until this point, I had always done like point-to-point soldering or use perf board because it seemed really complicated to learn how to make PCBs in software. I had tried to use Eagle and I hated Eagle, hated Eagle. And a friend of mine told me, you should just learn to use KiCad. So I decided to take the plunge, and I hated KiCad. But this is the first PCB I ever had manufactured by our friends at Osh Park. This was a huge step for me. It's very simple, and yet there are many fuck-ups. But it basically, and it sort of would fit on sort of the back on the top, right? So the teensy would go here. I found this excellent pogo pin part that you could use here. I found, some nice surface mount audio jacks and some SMD LEDs there, and a couple of horizontal mounted buttons. That was basically my concept. And there's the accelerometer attached by I2C, and this would plug in. I don't have a built one in this photo, sorry. But I did that and it worked and it was amazing. So I was like, oh, maybe this is a thing that could work. So then, after, I decided, I found out a lot of things were wrong about it. So I'm like, okay, well, I can do a much better job. First of all, it's awkward for it to be so tiny. It should be the same size as the Pocket Operator. Oh, don't go so fast. Go back. Sorry, this one. Thank you. So I made it larger. I got a better button. Just like some minor fixes. I figured out, I almost boiled the teensy on the other one and burned myself badly, actually, because I was running some current backwards. So I came up with this little bridge between the USB power and the battery power on the Pocket Operator so that you wouldn't feed battery power backwards through the regulator on the teensy and cause the regulator to overheat. So that was great and that worked. And then I was like, yeah, but those buttons are in the wrong place. And the slot was still really sort of floppy. And I didn't know how to hold the thing on yet. I was using some bolts through some holes here on the top. And then the bottom, I was still I had clothespins all over it. So I'd shake it 5 times and then a clothespin would fly off. And at one point I used Velcro and that was a mess. And I duct taped it and that was a huge mess. Next slide. I eventually figured out, you could use rubber bands across the top there and the bottom there, fitting in those little notches, and it works great. And you can just rubber band the two things together. So I used the rubber bands for that. I also figured out that you could use these capacitors here, little electric caps, just as a riser, as a standoff on the bottom. And that these switches that I found had a little sort of a notch on them that you could use as a standoff on the top, and you can really get a nice fit. So I got the two boards fitting together really well for the first time. I added this nonstop button because there was this sort of issue with certain Pocket Operators would turn off their play LED when you did certain things. And that would make this thing think that it should stop when it shouldn't. And there was no really good solution in the short term. So I just said, give me a switch for never stop making beats. So I called it the nonstop button. And I did some other things. I made these little notches here. We'll take the little folding metal stand that comes with the Pocket Operator, and you can fit it on this. So the whole package can sit on your desk, just like a Pocket Operator can sit. And I was really proud of that. It's still running the Teensy 3.2, which is a great board. You can see I screwed something up and had to do a bodge here. And I had to redo my diodes there, and it's still kind of a mess. And this is still very crude, but all of the basic concept is here. You've got the sound in and out. The buttons let you control whether it's reading beats or not, which is important. The accelerometer is there, and as ugly and basic as this is, next slide, I took it to a convention. I took it to Super Booth 21 in Berlin, where all of these synth people are showing off all of this gear. Moog has an entire circus tent there, for instance. And then I had a little teeny tiny little spot in a corner upstairs in a building where I showed this off to people and let them shake it and play with it, and showed them at this point that they could control with an analog sync signal, another synth that's just like some Korg Volca over there, and with MIDI out from the Teensy, like USB MIDI, I could control some video that was playing off of this laptop, just to show them the synchronization possibilities. And people would come up and I'd have them shake it and see it going faster and slower and stop and start, and they'd get it. And I had them sign up if they were interested over on the laptop here. And I got all this interest, and everybody wants to know when they can get one. I mean, half of the people are like, oh no, I do not use the Teenage Engineering toys. They are not Eurorack. But the other half of the people, everybody who already had a Pocket Operator, and there's like hundreds of thousands of those sold, everybody was like, yeah, this is great. When can I get one? I want one. How much are they? Where are they available? So I was like, oh gosh, this could really be a thing. So I decided to come back and look into crowdfunding it, and that's how I got involved with Crowd Supply. And it was right around the time that I was signing with Crowd Supply and getting started to bring that thing out, which was going to just be so simple. It was going to be that board cleaned up a little bit and get some teensies and slap them on there and ship it out. I thought I might need like 1 or 2 more revisions just to like get the little cartoon art looking better. But then the chip shortage happened, and suddenly, next slide, all the chips disappeared. This is what you get if you Google search for chips disappear. I had just agreed that I had this thing that I thought was ready to go and get manufactured, and suddenly you couldn't get teensies anymore. They couldn't find any of their chips, and they were completely selling out. You couldn't get almost any other microcontrollers. Like there's a huge shortage of those. I couldn't find a good codec chip in quantities that I thought I needed. I imagined I needed like 1,000. Everything was just drying up all over the place, and I didn't know what to do. And I felt like I was just like right at the cusp of having committed to do it at the time that it suddenly became really difficult to do. And I thought, well, this chip shortage won't last for a month or more than a couple of months. Maybe I can wait it out. But maybe that didn't happen. And I was like, oh God, I'm going to have to just basically design a new board. I'm going to have to go and find some controller that's out there, because there were a few still available. Design a board for it, and I guess learn how to do that, because I figured how hard can it be, and then I'll just port Arduino to that, because I figured how hard can that be. So this was version 5, and version 5 was like really time consuming. I learned, I had to learn so much stuff about just how you actually host a microcontroller on a PCB. And there's not one deep thing about it. There's a million details you have to get right, is what it is. But like at the same time, I put a bunch of work into this slot here, getting it to really lock right onto the battery connectors on the back of the Pocket operator. It really pops on there. It doesn't slide around and it doesn't twist. Getting that right actually took several more revisions, but I was going for that. And then there was this whole power system that was supposed to work. I had to get a USB-C connector going, because that's the future, and figure out which power management chip to use and all this stuff. And then I got it up like to the point it could blink. And then I was like, now it's just time to port Arduino. And then I seemed to realize what a mistake I was making trying to take that on. And then I was like, oh, well, the manufacturer's got their own dev kit. I'll just rewrite all of my existing code from scratch in this new environment. And I sort of look at that and I'm just like, no, that's a stupid idea too. And so I threw all that work away. I ditched it. I did carry over a lot that I learned, but I spent like a good 4 months designing this, and I was just like, this is just a mistake. Sorry. What other chip can you get in 2022? Well, there's 2 of them. One of them is the ESP32, and the other one is the Raspberry Pi RP2040. And I went with the Raspberry Pi RP2040, and I'm really glad I did. It is an excellent chip with fantastic documentation and really good support, and it does a whole bunch of things well. And it has been a joy to work with. I'm super into it. So this was the first version based on the RP2040, this guy right here. But the RP2040 doesn't have its own digital analog converter, so I had to do all of the audio with what's called PWM, which basically means I had to add all of this shit to filter out noise. These are output filters. So that added complexity, and then of course with the chip you've got to put down obviously a crystal and some management, but you've also got to give it its own external flash chip, and then that needs some management, and then it's like you're trying to make this thing either run off of 5-volt USB power or off of the Pocket operator's 2.5 volts of battery maybe, and the flash chip wants 3.3 volts. So I'm trying to get one power regulator that's a boost regulator and another one that's a buck regulator, and switch between them, and it was a mess. And then like actually right here, you can't see it all that well, but I got the wrong footprint for my main power chip, so this board never even would work. But it was a quick fix. So next slide. This was the first one that actually worked, and that's the actual footprint that's supposed to have. And this whole power system was really finicky and was kind of a mess, but the slot got a lot better, and I went to a different accelerometer, one that you could get in 2022, and that wasn't so bad. I got onto SPI with it instead of I2C, and so I got faster communications that way, which was good. They weren't able to get me the 6x2 Pogos anymore. Those were completely gone. But I figured out that these over here are just 2 extra grounds, and that's already a ground, and I could get the 5x2. So I bought every 5x2 that Mouser had. And now they're all mine. And everybody else did that with all the other chips. So, fuck those guys. But this was starting to work. My existing firmware would work on here. It would light up, and it would send sync, and it would do all of the things. And I was learning how the RP worked and getting things right. And there was, of course, some miswired stuff. I was constantly soldering it wrong too, because I didn't have a microscope yet. I just had those little sort of fold down googly glasses and like a headlamp that I would wear. And I'd just like get really, really close to the table with my tweezers and like lift shit up. And so I like put diodes on backwards all the time, and getting every pad right on this is a challenge sometimes because it's got very, very small feet. So I was struggling, but it was beginning to work. I finally had a debug connector that became really handy, etc. I guess next slide. This is the green one. It was Chinese New Year's. And at this point, I had switched from getting stuff done at Osh Park to JLC PCB simply because it was becoming clear that I was going to have to do a lot of iterations, and it was beginning to add up in cost. But they couldn't get me the purple ones because Chinese New Year, so I got green. And they couldn't get me the nice gold-plated stuff because Chinese New Year, so I got the ugly silver stuff, and I decided immediately I would never, ever ship a board that looked this ugly. I continued playing around with this idea. I made these little jumpers here instead of the little audio cable to connect the two boards, and it works really great, but this turns out to cost like 5 times as much as an audio cable, and I just couldn't really, and then getting them made was even hard, so that never really worked out, unfortunately. Maybe someday. But what else can I say about this one? Oh yeah, I did a smart thing on this. I decided to escape from 3.3 volt parts and just drop everything down to 1.8 volts. So it could all run off of either the battery or USB, and the power only needed to be dropped down. It never needed to be stepped up. And that meant that all of the voltage regulators that I could get were much simpler ones, and the power system started to work a lot better. So that was a good move. I really thought 1.8 volts would be fraught with all kinds of weird 1.8 volt problems because I'd never done that. But the only real problem is that I kept hooking up a 3.3 volt debugger to it and wondering why it wouldn't work. So once I figured out that I was doing that wrong, everything started to come together. There were still some little refinements to this notch. I kept every version. I was like going and like measuring and like there would be changes of like, tenths of a millimeter. And it's really amazing how accurate the manufacture of PCBs is. Like I've done stuff in print where you're doing like really little tiny details to move like little specks of font around. But the accuracy that you get on like the cutting machines and the printing machines on PCBs are like vastly more precise than that, which means that you can do like little teeny tiny artistic things. It's really fun, actually. I've come to really like KiCad, I think. I have to admit, it's weird, or I feel better afterwards, I guess. So yeah, we were getting there. So this was January 2023 of this year. Next slide. This is going to be version 8. This one, sorry, I'm keeping track here. No, that was version 8. This is version 9. Oh, it says version 9 on it. I finally started putting the version numbers on the board because I was getting super fucking confused. And it was getting really close. I had a problem with the USB power that I fixed. I just fixed some bugs, you know. I added this little pad here that I could just run the main clock output straight to and put it on a frequency counter, so I could figure out just how to get the crystal tuned exactly right. And I added these 2 extra pads for extra capacitors next to the crystal, so I could go in and say, how does it do if I add like another 0.1 farads on either side, and go measure it and then unsolder those and solder on a different one. So it's important to get that right because it just reduces your power consumption a lot and gives your crystal like a longer lifespan. This is what everybody says. So yeah, I was getting really good at this point. And I mean, meanwhile, I should mention, it wasn't just about getting the hardware right. There's all of this stuff in the firmware going on. Like the basic concept had been there, but then it was like, I needed to be able to switch these over from analog sync to serial MIDI. And I had to write all that. And then I had previously been using a whole audio library, and now I had to write my own audio library with PWM to go through this. And that was some time. And also, the more I worked with the thing, the more I got into all of these nuances about actually detecting what a person is doing with the accelerometer. And so like the algorithms and the technology for picking up the beat improved, I hope, through a lot of feedback. So I was just very busy with all of that. And then I basically would like design new boards, send it to the fab, and then go work on the firmware for a while, wait for the board to show up, and then board, go switch everything. Now I got to go do some soldering, and then be like, okay, got it done. No, it's not working. It's not working. I had so many problems with my soldering before I got a microscope. And so I would get a new board up, and then be like, new board is up, and then go back to firmware for a while, figure out what's wrong. So alternating back and forth. And I mention that because I'm constantly asking myself why this took so long. But it was no one thing. It just turns out to be hard to make stuff. This is my big lesson. But this was really close. Version 9, you know, I thought it was going to be final, actually. But I did a dumb thing with the debug interface where I thought I ran the power backwards. This is fixing that. And so I had to fix that. And I was also experimenting with different values in the filters in order to get a filter where, like, on the one hand, you can do RS-232 through it, but on the other hand, it'll chop off, you know, damaging high frequencies, aliasing off of your PWM. And there's like a lot of futzing. You know, this is when I started to own a bunch of expensive test gear. This is when I got a modern oscilloscope and a better power supply, and finally a microscope, which I think is probably the next slide. Oh God, I love this microscope so much. It's like my new best friend. I'm constantly saying, hey honey, look at this thing I found in my ass under this microscope. It's just fascinating. I got this used off of, the husband of a deceased Intel engineer. But it is the sort of like the cheap Chinese microscope these days called Amscope or something. It's got a physically klutzy, but the optics are really good, and I love it. And it's just amazing how well you can solder when you can see what it is that you're soldering. It's night and day. So that's my big takeaway: is why didn't I buy this like 10 versions ago? So next slide. This is version 10, release candidate. And this is actually the complete, correct, and final circuit of the board. But this QR code is illegible because this is the screen printing layer, and the screen printing layer, compared to all of the other layers, is actually really sloppy at JLC. So you couldn't scan this at all. It was a mess. So I had to do one more revision just for cosmetic stuff. So larger QR code, this font, larger, more legible, improve my little logo a tiny bit, took off the dumb thing that this guy was saying and just had him shut up. I added, you can't see it here because of the resolution of the projector, but this says dedicated to Stephen Lowell Innes, 1960 to 2015, a wizard, a teacher, a friend. I wish I had just a slide about him, but this is a guy who I met when I was about 11 years old. And in the computer lab at my school, in the 7th grade school in Palo Alto, California. He came in with this device in a little handbag around his neck, just about the size of a CB radio. It was possibly the first portable computer. He was a member of the Homebrew Computer Club. He was friends with Steve Wozniak and Steve Jobs and Captain Crunch and all those guys. But his computer only made sound. It didn't have a screen. It had a row of 8 dip switches on it and 8 LEDs and a couple of buttons, and it had a speaker. And it had an 8080 8-bit CPU in it. And he hand-coded all of these weird sounds in it. Does anybody know what bytebeat is? Bytebeat? Raise your hand. Okay, so Stephen Innes invented bytebeat in 1983. And he would play it on this thing and do a whole bunch of other things. And I just thought this guy was amazing. And he was super nice. And he was kind of an educator. And he was there to help kids learn about computers. And I was like, I want to learn about computers. I'm in the computer lab learning to program little snake games on the crude graphics and so on. And he showed me how a digital analog converter worked and helped me to build one. And he taught me about loudspeaker impedance and just like basic things. And became this guy who I could kind of call up at any hour of the day or night and say, hey, Steve, they're trying to teach me trigonometry and it hurts. And he's like, no, trigonometry is easy. Just take a pencil, draw a circle. Now see, this is this and this is this. And they're like, oh, that's trigonometry. He made everything seem so smart. He was a genius. He was really brilliant at electronics. He was way ahead of everything. He was working on he founded a company to make mobile telephones in like 1988, before cellular was a thing, just a few years before cellular. And you would have thought that this guy would have just gone really far because he was super talented in tech in an era where being talented in tech was everything. But like the last time I saw him, he was living homeless in Davis, California. He had, I don't totally understand it. I mean, he felt that he had been ripped off a lot by a lot of people he trusted, that he had had a lot of his ideas stolen. And even though he could easily find work, he was just very depressed. And he took his own life a couple years later. And it was strange to me when that happened, but and also I'd gotten out of touch with him. But when I heard about it happening, obviously it's a big thing to lose an old friend, but it also really took me at a moment in my life when I had gotten really sick of things I was doing and really wondering what I was actually here on earth to do, to really remind me of when I was younger and I was super excited about electronics and sound. And I would say he really inspired me then and now, and even in his passing, to turn back to that fascination with the physics, with signals, sound, music, tuning, information, noise, perception, physics, the entire basket of interrelated subjects that we touch on when we explore electronic music. So thanks for listening to me talk about my friend Steve. So today I stepped out of my home for 10 minutes to visit my wife in her studio in the backyard when the UPS driver came by with a box with 100 of these manufactured boards. And he'll be back tomorrow, and I'll get them. And they're going to be in little envelopes like this with little labels on them, because you have to have a nice label, because Mauser needs that for their control. And then inside each one of those is this nice little package. And you'll see, well, what is that? And you'll open it up and you'll be like, oh, that's funny. And in the inside, you're going to see, here's the rubber bands you hold it together with. And here's the finished version 11 board with a dedication to Steve. And here's the cable that plugs it together. Here's the little instruction manual, tells you how to plug it in and use it. I'm getting all of that assembled finally. Since this is an odyssey, since really like 2019, that's finally coming to, I mean, not its conclusion at all, because I'm going to send these out and then I'm going to start getting all of the email from people who can't figure out how they work. And I'm going to feel like it's all my fault, and we're going to work all that out over the following months. But it's very exciting to have come all of this way. And that's what's involved, for me at least, in making an electronic music product. Although it's hilariously, as much as I love music, this thing is a clock. It doesn't actually make any sound by itself, except for a small ticking noise. But still, I'm really excited to see what people can do with it. I really hope that it's going to help people to play electronic music in a different way. I really hope people are going to use this to synchronize all sorts of other equipment and play it in goofy, arrhythmic human ways. I can give a quick demonstration of this if we're all interested. And then the question would be, is it loud enough like this?
Use that mic.
Let me plug it in. Oh yeah, it's just use the mic.
Oh, I'm going to have to shake it around a lot, though. It's a problem.
Look, I just did.
Take the mic.
So there's a beat, right? As simple as that. Thank you. Thank you. All right, next.
Thank you so much, Mykle. That was really cool. Thank you for taking us through all of your revisions. It's really good to see how people actually get from their idea through their various prototypes to an actual thing. Yeah, slowly and painfully. All right, so for our last speaker of this evening is Matthew Rempes. Is it Rempes or Rempes, sorry, I butchered that. Who's going to come along and tell us a bit about his work and also talk about this amazing, his AV set here. So do you want, is it this microphone or do you want the other microphone? All right.
Okay. Do you mind pulling up the projector for the output of it? There we are. Okay. And I think I also have this. We'll check that when I get ready to actually put sound on. But yeah, thanks everyone. Everyone who's spoken so far, that's been amazing. Yeah, really great work. I think I saw you having a religious experience at that quadraphonic concert, actually. But yeah, it's been really great to hear from everyone. So my name is Matthew Rempes. I'm a video synthesist and a video instrument designer based here in Portland, Oregon. I'm one half of Foxing Hour. It's a modular video synth company. I met Fox online in 2021, and I didn't actually meet him in person until we met up at NobCon like 2 years ago. So it's kind of weird to like design 10 modules or something like that and never know who you're really talking to except for forum posts. But in any case, I'm here today just to talk a little bit about, well, one, what this box is. It's a video synthesizer. How I got into video synthesis and how eventually I got into designing these kind of modules. Then I'll end up blasting your retinas and ears with an AV set, but that'll come after. Yeah, so I think this all kind of started with me plugging an MP3 player in wrong in like 2008 or something like that. So I had one of those with the AV breakout cable, and I think just once I plugged the audio into the AV thing, and whatever CRT I had at the time, one of those old school boxy TVs, just like totally freaked out from it and made amazing looking visuals. I was like, what is this? So I didn't really understand what I was looking at that time. I mean, I think I could probably try to grasp it better on a technical level now, but yeah, I didn't really know why it was doing that. I just knew that I really liked it. At the time, I was attending a film school over in Dayton, Ohio, and the program was really like documentary narrative film focused. They seemed to think that anything that was just like pure abstract art was like this other stuff that other schools did. So maybe I went to the wrong college, but oh well. But they did have one semester on video art where I got to see some really amazing stuff that helped me realize that you can do a lot of interesting stuff with the medium itself. Like there's a lot of feelings that and just concepts that can be much easier to relate when it's like purely abstract imagery without trying to put like words and stuff to it, as I'm probably attempting to do now. Yeah, I think I remember asking one of my professors when we had some project due at the end that was like make some kind of video art, that I was like, is there any way I can just like directly generate video? And they looked at me like I was kind of nuts. And they said, I think you might be at the wrong university, which again wasn't really helpful when I was like 3 years on my degree. But in any case, I did some really bizarre stuff with taking multiple VHS tapes and like redubbing them over and over, and then doing like a triptych kind of installation for it, and it was fun. But all the processing that I did for it ended up having to be with gosh, I'm not even certain what program I used for it, but it was like really laborious rendering time on a computer, and I didn't really enjoy that workflow. Like by the time I had thought of an idea of what I wanted to do, like it was already passé. Like by the time I saw the result, I already wanted to do something else. I ended up moving to Wales after that for like 5 years or so. And I was in a really rural part where they had even less of an idea of what video art was, or what you might, why would you pop. Okay, no worries. Thanks for trying to make me audible. Yeah, so during that whole time, I think it was around that time that I started hearing like what Eurorack modular synthesizers were, which is like an endlessly fascinating concept to me, that you can just rewire the architecture of a synthesizer and you can do it physically. That every time that you decide to make a different aesthetic choice in your sound, that you're doing it right there in the moment. And yeah, it's really fascinating to me. I didn't really have the funds to get into synthesizers at that time. Also, another shout out to Synth Library Portland for making these kind of things more accessible, not having to spend thousands of dollars on them. Yeah, I think it was around 2010 that I heard about a company called LZX Industries where they're also based in Portland. What a wonderful city we live in, that there's like so many synthesizer companies. But particular to my interest, that there's like literally video synthesizer companies here. So Lars Larson and other folks who were involved with the development of that company kind of revived a lot of the analog video synthesizers that had been developed back in the 1970s, 80s kind of realm. After that time, people got, a lot of the artists who were involved in that medium got, I guess, either bored of analog stuff, or it just was, they were more interested in seeing what more primitive computers could do at that time. Either case, a lot of really fascinating development just kind of stopped. But in 2010, Lars kind of took on the mantle and started making these synthesizers available again. Unfortunately, still really expensive. I had no way to afford it at the time, so I just kind of drooled over photos of it and thought maybe one day. Quite a few years later, I ended up moving to Columbus, Ohio, and there I decided, okay, I really want to get started into analog video synthesizers. What can I actually afford? And another maker that I'd heard of around 2010 was Hiske. I think I probably butchered that. Thomas will correct me later, I'm sure. But in any case, it's a Dutch artist where he created a really compact video synthesizer called the Three Trins. Also, Thomas has made hundreds of them, and I think he cringes every time that I hear them. Hear me say that. But yeah, it was just this wonderful little box where it had 3 oscillators that were like tied into red, green, and blue. You could plug an external video source into it, whether it was a old school Sony Handycam, VCR, whatever you could find that just had an analog video source into it. You could colorize patterns, do all sorts of trippy stuff, and I thought, okay, I've arrived. This is the thing that I want to do. But as with any device that's hardware, you can kind of find this is limited. This isn't like there's only so much I can do with it. So once I moved to Portland and I was in the realm of synthesizers, we dived fully in. One really wonderful thing that LZX came up with, I think it was around like 2016 or 2017, is there was a series of modules called the Cadet series, where instead of having to drop like $2,000 or $3,000 on a full video synth, you could just kind of build it up in chunks like the functional blocks. So I slowly started building a larger and larger Cadet system. More and more time went by. I started having grander ideas that what if I do something in triplicate, since it's RGB color space? What if I start doubling things, and then we ended up with a larger video synth? I will be upfront, this isn't the only part of my video synth collection, but I'm not going to dive too much into what that wall looks like at the moment. But what I started getting into around that time, I think it must have been like 2018, 2019, I started seeking out other folks who were interested in like actually developing circuits and like finding ways to create like the functions that I had in my head of what if you could make video do this in the analog realm. Unfortunately, I found, as I mentioned before, Fox from Foxing Hour, who lives way up in northern Michigan. We just happened to connect on a forum, and we started tossing ideas back and forth. The very first module that we ended up designing together was just like me pulling a little bit of a schematic out from the Cadet series, which was how you make proper blanked analog video, and going, what if we just like plugged any old random signal into it? And we ended up making a high-speed multiplexing switcher. So you can do things like take signal A and signal B and switch really, really quickly, and then you essentially are able to composite images together. More and more silly ideas were thrown at Fox. He's an actual engineer. I'm not. I've just done a lot of DIY, and I think all of my all my electronics knowledge is like entirely based on I need to know this thing right now. Google save me, and usually that has worked out okay. I have blown up a lot of things, and there's been some smoke, but you know these things happen when you don't have the full picture. But yeah, we started developing more and more modules, and I think at this point we have like 14 of them out, and it's been really wonderful to see all these like just random thoughts that I've thrown at Fox, and seeing them iterated over time, and really seeing how like an incredibly niche synthesizer product goes from me just typing something at like 3 a.m. because I can't sleep to it actually turning into something that people buy and use as part of their creative practice. It's like really wonderful to see that. that point. One in particular was a video rate filter, which I unfortunately don't have in the rack here. But if you think of most filters in the audio world, the idea is that like low pass filters will let you only allow the the lower frequencies through. In video, that means you end up blurring things. High pass filters, that's like just concentrating into the highs. In video, that ends up giving you like contour extractions or just like the little tiny complex edges. And that took us like 3 years to finalize because it's really complicated to do stuff in video is the other thing that I found. Yeah, like audio is really quite forgiving. Video is brutal for like anything that you can do for it. There's like a lot of considerations that can either lead to a really interesting output or just like total garbage. In any case, we had a lot of iterations that I think yours were perhaps more functional. Ours were just like, oh god, that doesn't work at all. But yeah, I've been really fortunate to have this kind of collaboration where I get to whisper all my video synth dreams to someone who replies back with concrete, like real physical modules. And over the past couple of years, I've gotten a better and better sense of like how to really like look at a schematic and you go, that's that particular block, getting to the point where I dove into KiCad as well and have like thrown together my own modules. It's really empowering, I feel like, to go from a spot of being enthralled with all this stuff to actually making it yourself, and more so being able to share it with other folks in a concrete way. But yeah, I think one of the point that I kind of want to go back onto is in 2017, I got involved with S1, now Synth Library Portland, and the first workshop that I ever put on was with someone who was visiting town named Derek Holzer. And he's a really fascinating artist who's interested in like media archaeology, but his actual creative output is incredible for something called scan processing. And a lot of what you've seen on the screen here is kind of a mix of using this old school vector monitor that I have like tucked in the back there. If you're all familiar with like old school CRTs, like old color TVs, the idea is they're actually raster monitors, right? Where they're drawing an image from left to right, top to bottom, and just repeating it really, really quickly. With a vector monitor, the beam is arbitrary. Like you can send it wherever you want. You can do things like draw a raster with it, but you can also do like much more abstract things like just throwing some sine waves into it. You can draw a circle as you get more and more complex waveforms into it, and throw some things like 4-quadrant multipliers and all sorts of stuff into it. You can get like very dramatically interesting shapes. But going to that workshop and seeing Derek's work kind of led me down a rabbit hole. And I don't think I've collected all of the vector monitors, but I'm working on it. One approach that I've been exploring more recently with vector monitors is, if you're familiar with like video walls where there's like multiple monitors that they have an image split across them, I've gone down the potentially silly route of taking like 8 of them and stacking them in a cube and then drawing like an entire picture across them. But again, this is an arbitrary, you can send completely arbitrary signals into them, so the image is not fixed as like a left to right, top to bottom thing. You can have this quadrant go over there, this quadrant go over there, and it can be all sorts of weird goopy stuff. I don't have any examples to show of that today because it's way too heavy to bring out that many vector monitors, but if you're around Portland, you might see me do some increasingly ridiculous things with way too many monitors. But the reason I bring up that is because for my AV set, I am basically going to be taking some signals that are generated within this Eurorack video synthesizer, just oscillators. So everything in the video realm goes way, way quicker than audio. Like if you think audio is roughly like 20 hertz to 20,000 hertz, or if you've been to way too many noise shows, it's like 14K or less. But yeah, like the oscillators in here go up to like 3 megahertz, totally unnecessary in the audio world. But that doesn't mean they aren't producing lower subharmonics or partials, so you can still hear them. So we're going to end up hearing like what these speakers are capable of putting out. They definitely are not going to squeeze out 3 megahertz and you're not going to hear them. But we're going to see the other remainder of the signal up here. Essentially the signals are going to be generated within here. I'm going to be sending them to this vector monitor. where it's deflecting the beam this way, and the intensity of the beam can be controlled too. We're rescanning it with a camera that's being brought back into the synthesizer so I can turn it into a patchable format. I'm just using like regular 3.5 millimeter cables. Amazingly, video will go through that without just turning into a potato. And doing some weird mixing with it. So you'll end up hearing the result and seeing the result up on here. But yeah, I think that's pretty much what I wanted to cover. Did anyone have any questions about my silly little journey in the video? Yeah. I don't think so, off the top of my head. Awesome. I mean, I would love to do that personally myself. Awesome. Great. Yeah, it's always curious to me how people get acquainted with abstract video art. I mean, I feel like for a lot of folks, particularly anyone like my age, you would have seen it like on MTV. That would have been like your first introduction to anything approaching video art. But yeah, I think the first thing that I saw that could even be like considered abstract video art was like Joan Jonas's Vertical Roll, and that was in that video art class that I watched where they just messed with the way that the synchronization pulses worked and turned it into this like really visceral kind of sledgehammer sound over time, which is great. Yeah. Any other thoughts or questions? Yeah.
When you're working at like 3 megahertz signals, you have issues with the signals like leaking out of the jacks or like spreading through your kit without cables.
So the
Can you repeat the question, please?
Yeah.
Sure. Yeah. Yeah. So you were wondering with having as wide of bandwidth in the system, going like having an oscillator that goes up to 3 megahertz, do I have issues with like EMI in the system or just like noise?
Leakage between ports that aren't connected.
Not too bad, honestly. There's a particular way that all of the inputs and outputs are buffered that really helps prevent that from happening. But really, the past entire time I've had a video synthesizer, noise has been my enemy. The power boards that I have in here are like as close to lab grade as you can get without spending way more money on it. They're like, what is it, like 5 millivolts peak to peak kind of noise on the rails, so it's not too bad. But this entire the way that this whole system works is that like your rack is often like 10 volts peak to peak, like plus minus 5 volts. In the way that they set this up to maximize kind of a lot of the tricky things in videos is that it's unipolar 0 to 1 volts. So even like 10 millivolts is something that you could see as a signal. So like noise is really perceptible in this. So often what I do is just like lean into it. This isn't actually like the noise in like a stable pattern, but it'll let me see if I can pull this back a bit and stop it rotating. Yeah, I think I have enough. I have enough going on in this patch that it may not be like immediately obvious, but yeah, like particularly vector monitors, they are brutal for showing you every last little bit of noise in your signal. So to a certain extent, you just go, okay, I if I really wanted this to be clean, I should just use Touch Designer or something like that. Yeah. Any other questions? Okay, great. Well, I am going to make some noise and blast your retinas. Feel free to run screaming if you like, but you know, thanks for listening. That is wonderful. One wonderful thing with vector monitors. Yeah. So just to repeat that, does anyone want to guess when I had the beam on the vector monitor completely pointed like off the tube somewhere? That's one of those wonderful things about analog things is like they will do pretty much exactly what you tell them, I think. In any case, thanks for checking that out. Appreciate everyone's attention.
Super awesome. Thank you so much, Matthew. And thank you to everybody who spoke tonight. You did an amazing job. Now, I know there's absolutely loads of really cool projects on the tables. We've got synthesizers to play with. So please stick around, drink some beers. I'll refill the sink with more drinks. Please talk to each other. Also, just so you know, we do have a Discord now, so you can jump on there. And my friend Bo, who I'm going to be helping set up Sound Hackers Oakland when I go through there. He has put a bunch of links there. So if you want to find out more about people's works, there's the people at the speakers tonight. Oh God, my sentences aren't coming out correctly. It's the end of the night. Yeah, so there's links there. There's, you can chat there, you can share links, etc. We also have, just in case you didn't notice it, we also have a sticker swap. So feel free to put your stickers in there if you brought any, or take them. Ditto, there's like a leaflet drop, and there's also right at the back there's a community notice board, which is, this is the first time we've done it, but it's, the idea is that you can put up your postcards, or like if you're looking for something, or if you're running a workshop, or you've got a new board out or whatever, you can stick it on there. So please, if you've brought anything, please put it there. There's paper and so on as well. If you're looking for help on a project, for example, you might want to pop it up there. So I've told you about Discord. I've told you about the different things at the back of the room. Yeah, just stick around, have a nice time, play some music, have a good time. Oh yes, tip jar. Okay, so the tip jar is. I will have it in my pocket. It's over there. Okay, so there is a tip jar. Is a jar with the post-it note on it. I will put it at the front here. So please, if you enjoyed this and you enjoyed your free beers, please give a few dollars, and we will split that between the artists on the way out. Aside from that, thank you so much for coming and being a supportive audience. This is our second ever event. So yeah, like massive thanks to the 4 speakers, and of course the amazing Leroy, who's been doing AV this time. So I didn't have to do it like last time, which is amazing. Thank you so much, Leroy. And also huge shout out to both Bo and Noel, who are online handling our Discord and YouTube comments. So I'll see you in February, I think is when I'm going to. Yeah, that's it. We're done. Thank you, everybody. Drink the beer. Have a nice time.
All right, well, hey everybody out there, I hope you enjoyed the show. And we're going to wind things down here with a bit of the show of our own. Just going to adjust the audio here a bit. Well. Oh, okay, let's try this again with the mic a little bit closer to where I am. So we've got Sound Hacker here with us, who's got the modular setup. So we're going to go ahead and switch over to that, and we're going to throw together a few patches on the fly. And really glad everybody came and joined us. And, hope you enjoyed the video. This is a bit of an experimentation for us all here, and we hope to dial it in. And please do pop into our Discord, and we'll look forward to the next go around here. So we'll hope to take a few warm from past and make it even better for Portland. And then, as Helen mentioned, we're looking forward to doing some meetups down here in the coming months in the Bay Area as well, and wherever you are. If you're interested in jumping in, then we'll look forward to connecting with you guys in person or remotely as well. So I am going to turn this over to Winkies, and you all enjoy the light and the sounds as we wind up our evening here from thanks to the whole crew up in Portland there, and we'll look forward to seeing you at the next one.
This is the Portland Synth Library synth. I have no idea if you can hear me or not, but here we have some Synth Library modulars that have been brought in so we can play with them. It's our little AV station. Wait, I'm gonna move over here. Here we have, this is the setup from the AV set. Here's the AV setup.
On the internet.
Yeah. And then this is the little camera. This is the table of Lara. This is the really cool, some cool modules. This is the sewing machine that we were playing in. A little stump box. All right, now let's go over to some of the project tables. And
And then like that's a music player. If you're dividing by 5, you're getting the blue, like this is 6 players, and then some minor players.
this is a cool DIY keyboard. And we have and we have, this is like a trigger situation with Ableton. I don't know what it was, but there was a guy here who was showing this off earlier. And that's, oops, let me go back to I'm so sorry, the synth library places. You can take a look at that. And then I think I've shown you pretty much everything. All right. Back we're here to the Portland Synth Library. Boop, boop. I have no idea if anybody can hear me or not, but that's basically it. I'll let Bo sign you off. I can't hear anything, so thank you so much for all your work, Bo. I'm off.
All right. Well, thanks to Helen there for giving us the tour of what's going on in the sound at the Crowd Supply office there, being our lovely host for the Sound Hackers 2 live from Portland. So once again, we appreciate you all being along for the ride and hope you enjoyed the presentation. We're just kind of stretching our legs here and seeing what we can do with this remote setup, and look forward to seeing you all at the next ones. And I'm going to return us to the lovely sounds and mixes here coming from Circuit Launch in Oakland, and hope everybody has a great night out there. So enjoy.